Hi, my name is Sergey, and today we will be talking about hardware and all computer components, how they connect to each other, how they operate, what their responsibilities, and so on. And we will start from power supply unit. Computers primarily use direct current, DC, as a power source. Most electronic components within computers, such as microprocessors, memory chips, hard drives, operate on DC power. However, power supplied to computers from electronic outlets is typically alternating current, AC, which is converted to DC through power supply unit, PSU, before being used by computer internal components. Level of DC voltage within computer varies depending on the specific components and their requirements. However, the DC voltage supplied by power supply unit to the computer internal components are typically standardized. In desktop computers, main DC voltage outputs from PSU are 12 volts, 5 volts and 3.3 volts. This voltage are used to power different components within the computer, such as CPU, GPU, motherboard, storage drives and peripherals. The exact voltage and current ratings can vary depending on the design and power requirements of the computer. However, there are some common voltage levels found in the desktop computers' power supplies. Laptops, computers may have different voltage requirements due to their smaller form factor and power efficiency consideration. Next components we will be talking about is CPU, Central Processing Unit. Is a mastermind to handle all calculations and instructions at lightning speed. CPU is the heart of computer, it's a brain of computer, but different CPU have different strengths. Understanding core count, clock speed and processing power will help you to understand which CPU you need for your current program. Processing power is how fast your computer gets things done. It depends on both factors. First, more core are great for multitasking, meaning handling many tasks simultaneously, and higher clock speed is great for single core tasks, doing one thing very fast. The ideal CPU depends on what you used your computer for. Gamers and video editors often need high core count, because, for example, one game can split different tasks on different cores, video processing for one core, audio processing for second core, NPC processing for third core, and so on. But for basic tasks like web browsing, might be fine with fewer cores, but with good clock speed. Talking about cores, this refers to a number of independent processing units within a CPU. Each core can handle instructions and calculations simultaneously. More cores allow your CPU to tackle multiple tasks at once, improving multitasking performance. Clock speed, measured in Hz or more commonly known as gigahertz, clock speed indicates how many cycles a core can complete within 1 second. A higher clock speed means a core can process instructions faster, leading to quicker execution time of a single-threaded tasks. Processing power influenced by both core counts and clock speed. More cores and higher clock speed generally translate to a better processing power of CPU. However, other factors like cache size and architecture also plays a role. In simple terms, core count is like having multiple workers, while clock speed is how fast each worker can complete their assigned tasks. Processing power reflects how much work your CPU can handle overall. Similar to CPU, most computers have GPU, graphic processing unit. It is a component similar to CPU, but with one main difference. While CPU is designed to be versatile, GPU is designed to be fast with parallel. That's why it's very popular when we're talking about AI development or cryptocurrency mining, because GPU has more cores, it can more efficiently calculate blocks or in cryptocurrency blockchain, or it can predict next hallucination of AI. While modern CPUs can have 24 cores or 16 cores, modern graphic cards can have over 60,000 cores, and this is crucial for specific tasks. Because memory matters in the computer, let's talk about short-term memory, random access memory, also known as RAM. It acts like a whiteboard, temporarily storing data the CPU needs for immediate tasks. RAM has been a fundamental component of computers since the early days. The specific technology has evolved over time, but the core functions of providing fast, temporary storage for CPU has remained constant. RAM acts as computer short-term memory. It stores data and instructions that CPU needs to access immediately. The faster your RAM, the quicker CPU can retrieve data, leading to smoother performance. RAM comes with different capacities and speed. Capacity measured in bytes or nowadays in gigabytes. More gigabytes allow you to store more data for GPU. Higher speed means CPU can retrieve data from RAM even faster. The CPU directly uses RAM. When you open a program, a CPU loads necessary instructions and data from storage, like your hard drive, into RAM for quicker access. A CPU works on the program. It constantly interacts with RAM for data retrieval and storage. The operating system, like Windows, macOS or Linux, manage RAM allocation. It decides which data and program to store in RAM based on currently being used. It also handles swapping data between RAM and storage when RAM gets full. Additionally to memory, we need to talk about storage options, about long-term storage. Hard drives, HDD, and solid-state drives, SSD, holding all our files, documents, and software for a long term. They come with different speed and capacity, each with its own advantages. From traditional hard drives to faster SSDs, storage options continue to evolve. Both HDD and SSDs are forms of persistent storage, meaning they retain data even when computers is powered off. This is crucial for storing your documents, files, operating system and program. Like this compact disk, HDD uses a spinning disk and magnetic read and write head to store data. Similar to record player, the head reads and writes data on specific location on spinning disk. So disk is spinning and head try to find different location of a file and to display for us. HDD is usually cheaper and offers larger storage capacities. Accessing data involves physical movement of a head, leading to slower read and write speed compared to SSDs. Moving parts make HDD drives more prone to damages from physical shocks or vibrations. SSD uses flash memory chips similar to USB, like this or this, to store data electronically. No moving parts involved. Data access is significantly faster than HDDs due to lack of moving parts. This transfers to quicker program loading time and overall system responsiveness. Less prone to physical damage due to absence of moving parts. SSD generally more expensive compared to HDDs. While capacity are increasing, SSD typically offers less storage capacity than HDD for the same price. Understanding RAM and storage is crucial. RAM is fast but temporarily. Storage holds data permanently, but it is slower because you need to access drive. Even if it's a solid-state drive, you still need to access it, and it's slower than operating with random access memory. Important part of every computer is motherboard. It can be small, like this in Raspberry Pi, or it can be bigger for your laptops or desktop computer. It depends how many components should be tied together. Why it is motherboard? Because it combines all components together, and it defines which components it will support. For example, if your motherboard supports support port for RAM DDR3, it means it will not support RAM of DDR4. And also, why it is mother, it is also related to connector type, because in hardware this is a connector type of father, this is a connector type of mother. If you're putting something in, it is a father connector. If you're putting something to it, it is a mother connector. So I'm putting father to mother. That's why this name's kind of mother. And second meaning, because it connects different components together and define how they will be connected and talk to each other. Also, it's important to mention that every computer has input and output gateways. They allow you to interact with the computer and exchange information with outside world. Everything what helps you to input data to your computer is input gateway. It can be your mouse, keyboard, microphone, everything that instructs and add information to your computer is input. Everything what outputs information from your computer is actually output. Monitor is output because it shows visually what computer wants to display us. Headsets is output because it outputs sound which is stored in our computer. That was an undercover crew of our computers. I hope it was informative for you. Probably you learned something new. Please share in a comment what you learned new, or if you have any questions, please do not hesitate to ask. And see you in the next video.